Hello, today we're going to talk about functions. All right, first we're going to talk about a couple things about functions or about graphing or whatever you want to talk about. A relation is just a set of ordered pairs. So for an example, A, B, 2, 4, and -3, 2. All right, those are all just a relation. So AB is a relation, 2, 4 is a relation, -3, 2 is a relation. Most of the time you just call them points. A set is when you group, it's a group of relations basically. So if I take what I had here and I put these fancy little things around it, right? That is a set. So here I have a relation. So this is a relation, this is a relation, and that's a relation. I take those relations, I group them together, put these funny little symbols around it, and that becomes a set. A domain are the x values or the first point in the pair. So domain, domain, domain. So my domain of this is A, 2, and -3. Range, if domain is the x values in the first point, range is the y values, and or you can call it the second point. Now the range of all of this will be, again, all the second points. So A, let's use green. So my range is all of my second points. So B, 4, and 2. So relation is just a set of points, or just points. Taking those points and grouping them makes it a set. Domain is the x values of that set. Range is the y values of that set. All right, now this is ways of showing your set. So if you have a set that's a function, one way to show it is mapping. You have two ovals. This is your domain or your x values. This one is your range. So my domain here is A, 2, and -3. And let's just mix this up and say 4, 2, and B. So now all you do is just cross over and point to what the domain matches with the range. So then AB, 2 goes to 4, and -3 goes to 2. That's called mapping. From a table, you've seen a table before. You just write the points out. AB, 2, 4, -3, 2. So these are your domains, these are your ranges, these are your inputs, these are your outputs. From a graph, you just graph the points. So I can't graph AB, so I graph 2, 4, and -3, 2. All right? And that is how you show a set of relations in mapping, table, and graph format. All right, now I'm going to show the domain and range of a graph. So whenever you have a linear function, the domain and range is always the same, unless it's like a piecewise or it's not continuous. So if I have a line here, my domain here, and range. So what these arrows at the end mean is that this is going forever and ever that direction, and also forever and ever this direction. So since your domain deals with your x values, when you find the domain, you're only looking at the x-axis. So just completely ignore that the y-axis exists. So where on this line is this line gonna go to? Well, it's gonna go forever and ever in the positive x direction and forever and ever in the negative x direction. So your domain is actually all real numbers. You can also write that as negative infinity to infinity. All right. I know you've probably never seen that before, but just something new. So now, let me put my y-axis back in. Now where is this line going on the y-axis? Well, it's going forever and ever in positive direction. It's going forever and ever in the negative direction. That's what these mean, is they're going for eternity. So this is always all real numbers also. Or negative infinity to infinity. And that's for a linear function. That's the domain and range. Now, if you switch this over, and let's say we draw a happy graph. I'm actually going to do this in two different colors to make this a little bit easier. And we're going to do 3, 3, and 1, 2, 3, 1, 2, 3. We're going to draw a parabola. A parabola is the shape of, that's not a good parabola, but the parabola is the shape of a quadratic. So this is finding the domain and range of a quadratic function. Right? So you do the same thing. You're looking for the domain. All right? So just ignore that the y-axis is there. Look at the x-axis. Now this could be tricky at first. Since this arrow is going in that direction, and this arrow is going in this direction, you have to have some abstract thinking here. You can't think in one little tiny box. You need to think outside of it, and that's where this can be an issue. So think of this line. This line is going to go forever and ever and ever that way, for all eternity. Same thing with this line. So where is this line going in the positive x direction? Well, it's going forever and ever in the positive x direction. If you just ignore the y-axis, and it's going forever in the negative direction. So your domain is all real numbers, which 99% of the time it will be all real numbers. Now what will be different is your range. Stick with the green. Now my range, looking at the y-axis, let's get rid of this. All right? This is 0 right here. So where does this go down to? Is it going all the way down here? No, it's not going that far in the negative x direction. So it has to stop somewhere. So where is it? Where does it stop? Well, it stops right there at 1. So 1. But is it going to be everything greater than the 1 or everything less than the 1? That's what you have to think to yourself. So this is going to go forever and ever in the positive direction. This can go forever and ever in the positive direction. So it's actually, your y is going to be everything greater than or equal to 1. So what's that saying is, your range is every number greater than positive 1. And that's how you write your range for that. All right, and here we go. Here's another one. What's my domain here? Well, on the x-axis, it's going forever and ever in both directions. So it's going to be all real numbers. And that's just based on looking at the x-axis and these two going forever and ever out that way. So what is my range? Well, my range doesn't go forever and ever in the positive direction, but it does go forever and ever in the negative direction based on these arrows. They're going to go down and down forever. So y, and then where does it stop as it's going positive? It stops at 2. Now, is y going to be everything greater than 2? No, because that would be 3 and 4 and so on. Y is going to be everything less than 2. So 1, 0, negative 1. So it's everything less than or equal to 2. All right, now I'm gonna show you one more while I'm here. All right, this is not a function because of the vertical line test, but you can give the domain and range if you want. If they ask you for the domain and range of this for some reason, the domain here stops right here at 2. So it's x is everything greater than or equal to 2 because it's going in the positive direction. The range would be all real numbers. So whenever it's going in the positive direction, it's always going to be y or whatever is greater than. If it's going in the negative direction, it's always going to be y is less than. All right, here are a couple examples for you, just to go over some function stuff. So which one of these is a function? So in a function, you have inputs and outputs. So you only have one input for every output. So if you do your domain here, you get A, B, and C. All right, do any of those repeat? No, and they all have different y's, so this is a function. If you have any more questions about functions, I have other videos. I have a whole thing of identifying functions from table sets and that stuff. You can go look at that. Now here, since all my a's are the same, all right, so my domain is A, or my range is the same, or the same. So if I had AA, and AA, I'd be good. If I have AA, then AB. So this is not a function. Domain is just all your first points. Your range is all the second points. Since they're all the same, all I have to do is put 1. And that is a function, because none of the domain or the x's repeat. Now over here, this is important to know that it says find f of x equals -4. What that means is f of x is the same thing as y. So when it says f of x equals, f of x equals 6, that means your y is 6. So this says f of x equals -4. That means our y is -4. So I plug it in and I solve. So here my x is -8. All right, 2 more examples, but these are of linear functions. So in a linear function, you have a straight line. All right, so this wants you to graph it. We're gonna make a table here. So x, y, with the function in the middle. So all this is just basically showing you how to plug stuff in. So -1, plug it in. So 2 times -1 minus 3, -5. Plug in 0 times 2, you get -3. Plug in 1 is -1. So to graph that, you're just plugging in points. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So -1, -5, 0, -3, 1, -1, and graph. All right, the ordered pair over here. So what's the ordered pair of the function f of x equals x minus 5 when f is -1? So what this is saying right here is that your x is -1, and it wants to know what the y is going to be. So I plug in -1 everywhere I see x. So this is basically saying y is -6. So your point here is -1, -6. All right, I just realized this lesson is way too long to do in one video, so I'm going to do a second video. So this can be called functions A, and then I'm going to do a functions B to finish up the rest of it. I hope this helped.